So I set you a few questions in the previous video on the more complex linear functions that we covered. What I'm going to do in this one is I'm going to go over them with you, work through the solutions and just give you an answer to compare to. Quick refresher for you about the questions though. Here you go, there's with the three of them, so calculate the derivative of each of the following expressions. So first one was f of x is 2x minus 1 to the power 4. Second one, y equals 1 over 4x plus 1 cubed. And the third one was f of x equals the cube root of 6x minus 1 squared. So here we go. So the first one, f of x equals 2x minus 1 to the power of 4. Now remember, for these sorts of more complex expressions, we want it written in the form ax plus b all to a power of n. We want it written like that. So it has to be done like this. Now this one here is in that form already, so we don't need to worry about mucking about with it or using any other laws of indices. We can just straight up calculate f dashed of x. Now remember what we said in the previous video, bring the power down, reduce it by 1, but then multiply it by the derivative in here, which in this case is just a. So break it down and do it step by step. Power down, 4, multiply it by the bracket, 2x minus 1, reduce the power by 1 is cubed. We then multiply it by the coefficient of the x in here, which in this case is 2. It's then a case of simplifying this and making it look neater. Multiplying these back together, and we get 8 bracket 2x minus 1 cubed. So we end up getting that. It's always the same sort of form. If it's ax plus b, it's only the coefficient of x that comes out and we worry about multiplying. As we hit advanced higher levels above here, we'll start to look at more complex expressions and things in here, but right now that's what we're going to worry about dealing with. Second question was y equals 1 over 4x plus 1 to the power of 3. Now this one isn't quite written in that form yet. It's on the bottom of a fraction, it's the denominator of this fraction. So we have to make it into that form. Now remember, when we're writing that, if we take an expression part here on the bottom and bring it up, this power becomes negative. So this becomes 4x plus 1 to the negative 3. Now that it's written in the form we want, we can simply take the derivative. So y equals this, it's dy by dx. Again, remember, pay attention to this bit, whether it's a y or it's an f of x or it's an f of t or something like that. We have to make sure we get that bit right. So dy by dx equals, and it's the same steps. Take the power, bring it down, reduce by 1, multiply by this bit in here. So bring the power down, negative 3, right out of brackets, 4x plus 1. Take 1 off of here, so negative 3 minus 1 gives me negative 4. We then multiply it by the coefficient of the x in here, which is the 4. Then it's a case of simplifying it. So I end up getting negative 12 bracket 4x plus 1 to the negative 4. And again, sometimes it might say write this expression with a positive in this, and in that case, this part here with the bracket has a negative power, so it becomes the bottom of the fraction. So it becomes the denominator, and we get negative 12 over 4x plus 1 to the power of 4. So we get something that looks something like that. But if it doesn't say to you to do this, this version here would be perfectly acceptable and fine. Third question was f of x equals the cube root of 6x minus 1 squared. Now again, this isn't quite written in the form ax plus b to the power of n that we want it written in. So we have to think back to National 5 and our rules of indices and how we can modify that. Think back to that, we can write it as 6x minus 1 to the power of 2/3. Remember, the denominator of this fraction comes from the roots, the numerator comes from the power it's raised to here. Now that it's written like that, we can just jump in and do our derivative in the exact same format. Yes, there's going to be a fraction there, but big deal. It's a fraction, it doesn't change how we do things. So we still start in this case with f dashed of x, and we still start the same way. Power down, reduce by 1, then multiply by our coefficient in here of x. So power down, 2/3, bracket 6x minus 1, take away a full 1 off of that, and I get negative 1/3. It's then going to be times by the coefficient in here, which is 6. Start to simplify that down, so 2/3 of 6 gives me 4. So I get 4 bracket 6x minus 1 to the negative 1/3. Now again, if it doesn't say anything about indices and about having a positive index, this would be a perfectly acceptable final answer. If it does, we'd have to make sure we modified it. So it's a negative index, it goes to the bottom. So 4 over 6x minus 1 to the 1/3. And again, remember, fractional index here talks about a root. In this case, 1/3 gives me the cube root. So my final answer will be 4 over the cube root of 6x minus 1. Just like that. Calculating these derivatives is the same. We always have to make sure it's this form. If it's in this form here, we can nail it straight away and get it going. And again, like I've said, don't worry about if the n is a negative, if the n is a fraction, or if it's just a nice simple positive number. The steps are the same every single time. All that happens is you might get a bit more of a complex number. Big deal. Hopefully you can handle it by this point. Hopefully they went well. I'll see you in class.